students, welcome to GATE IISc Academy. This is Verna. So in the last class we have already completed the limits and continuity. So today we will be discussing about the maxima and minima. That is, what are the increasing functions, decreasing functions, and what is the maximum value of a function at what value of x, right? There will be a maximum value or the minimum value, or at what point there is a extremes like maximum value and minimum value, right? So guys, let us discuss today about the maxima and minima. The functions which are decreasing, increasing, what are these are known as, right? So let me take a function y equals to f of x be the function. If the dy by dx, what is dy by dx? For the function, what is the dy by dx? It will be a slope. Dy by dx, the slope at any point. If it is positive, greater than 0 means positive slope, then f of x is known as an increasing function, or f of x is increasing in that interval or in that point or at that point, right? So wherever there is slope which is positive, greater than 0 means positive slope. How a positive slope looks like? If I take xy coordinate like this, so positive slope will be like this. So this is a positive slope, because here as x increases, even y is also increasing. So that is why the dy by dx will be positive. Change in y and change in x, both are positive, right? And here this is a negative slope. Negative slope means what? As x increases, y will be decreasing, or y increasing, x will be decreasing. So slope is greater than 0 is known, function is increasing. The f of x is known as an increasing function if in the interval wherever there is a greater than 0, that is positive slope. If dy by dx is less than 0 means negative slope. Whenever there is a negative slope, then the function is known as decreasing. The function will be decreasing at those points wherever there is a slope which is negative. Here slope is negative, the function is decreasing. Here slope is positive, the function is increasing, right? And if dy by dx is 0 means slope is 0. What is the 0 slope means? It is like this, just a horizontal line which has 0 slope, right? Dy by dx equals to 0. If slope is 0, then f of x is what? Stationary, right? Then f of x is stationary, means neither increasing nor decreasing. So in this figure we can see it here in this curve. At this point, the peak point, dy by dx is 0, means change in y with respect to change in x is 0 here at this point, at the peak point, right? Here you can say the function is stationary here, neither decreasing nor increasing. But consider the points at this region, right? In the upper hill region, uphill, right? So here, if you take any points and if you draw the tangent at those points, that tangent will be a positive slope like this, right? Means dy by dx is greater than 0, positive slope is there. So at these points we can say the function is increasing. Here function is increasing here. With respect to x, the function is increasing, means y is increasing as x is increasing, the function is increasing, right? Now here in this region, downhill region, any point if you consider and draw the tangent to the curve at that point, then you can see a line which are like this, which is negative slope line. So it indicates the function is decreasing at those points, right? So this is a increasing function is increasing here in this zone. Here function is decreasing wherever there is a negative slope, and wherever there is a slope which is 0, that is horizontal lines, then you can say function is stationary at those points. Now in any interval a comma b, any closed interval, the square brackets means closed interval including the a and b, d square y by dx square, what is this? The second derivative of the function. First derivative will be a slope, right? Second derivative is slope of those lines, means slope of those tangents. The second derivative is positive. If in case you get the second derivative as positive, greater than 0 means positive, then you can say that the f of x, this is to know the nature of the curve at those points. How is the nature of the curve? The function is concave up. So this is concave upwards. This is a concave curve, right? Concave curve is a concave upwards. So whenever the d square y by dx square or the second derivative is positive in this interval, right? A comma b. In these intervals, if the second derivative comes out to be positive, then you can say in that particular interval the curve shape is like this, the concave shape, right? Or you can say concave upwards, or it is like this. See, all are the representation of the same curve, which is concave upwards, right? Not only this one, even the half part or this half part, all are same only. The second derivative in this zone is positive. Here also the second derivative in this zone, concave curve, positive, right? So in this case also second derivative is positive only. Now d square y by dx square, that is second derivative of the function, if it comes out to be negative, at which points? At the interval of a comma b, at x equals to a to x equals to b, in between those points. If the second derivative comes out to be a negative value, then f of x is concave downwards, or you can say convex curve. Convex is like this, or you can say concave downwards. From the downwards it is concave or convex up. So whenever the second derivative is negative, it is a convex curve, convex, like this. You can take the first half or the second half of the curve. So any of these natures represent the same thing, that is second derivative positive only. Sorry, second derivative is a negative here, positive is here. For the concave, second derivative will be positive. For the convex nature, second derivative will be negative in these intervals a comma b, right? The point where f of x changes from concave up to concave down, or vice versa. Vice versa means concave down to concave up, means wherever the curve is changing its shape from convex to concave or concave to convex, the change of the shape of the curve is observed, then that point, at what point there is a change in shape of the curve, that point is known as the point of inflection, right? So here you can see the curve here. This nature is convex here in this zone, and after this point the nature of the curve is concave, correct? Until here it is convex, but from here this point it is concave. At what point there is a change in shape of the curve, that point is known as an inflection point or the point of inflection, right? So as here in this curve, the nature of the curve, you can see that the curve is, once it is going to a maximum value and then minimum and then a maximum at some interval, then minimum, right? So this is the curve that we will be analyzing. So here, see, at point P, what will be the slope y dash and what will be the second derivative, that is y double dash of the function, that is d square y by dx square. So as we observe here, y dash is obviously 0. Slope is 0 at P. Why? Because it is a peak point. Peak point, what happens here, if you draw the slope, it will be a horizontal line only, right? At that point, slope is nothing but the horizontal line, and horizontal line has 0 slope. So y dash is 0. Y dash means slope only. So y dash is 0 here, 0 slope. But what about y double dash, the second derivative? We know that at any point you observe the shape of the curve. If it is convex, then double derivative is negative. If it is a concave curve like this, then double derivative is positive. But here at this point, if we observe the curve, then what kind of a nature the curve has? That is a convex shape it has. Convex shape means double derivative is negative, means second differentiation of this function with respect to x at this point means x equal to a, then it is a negative value you will be getting. Now observe the point Q. At point Q also I can say the slope is 0. Slope means y dash, because even at this point, if you draw the tangent at Q, it will be a horizontal line, and horizontal line has 0 slope. So y dash is 0. Y dash means slope. So y dash is 0 at this point, which is at x equals to b. Y will be 0, means y dash, sorry, y not y, y dash means y dash is the slope. Slope will be 0. Y double dash is positive. Why y double dash is positive at Q? Because if you want to know the nature of curve at any point, then always look at the y double dash, that is second derivative of the curve or the function, second derivative of the function. At that point, if the second derivative of the function comes out to be positive, right, then it always has the concave shape, this shape. But here, as we are observing it from the nature of the curve itself, it is having the concave shape, then I can also conclude that double derivative is positive, of course, at this point, which is x equal to b, right? First derivative is 0, second derivative is positive. Now observe at R. At R also the results are same as P, because here also slope is 0, so y dash is 0, obviously, and here also double derivative, that is here also the curve has a shape of convex, right? Convex shape means double derivative is negative, and similar to that Q, here S has the same results, that is slope is 0. Always the extreme points, right, slope is always 0, because tangent will be a horizontal line. So even at point S, the slope is 0, y dash is 0, y double dash is positive. The second derivative is positive because it has the convex shape here, right? Now points P and R, we can say them as the local maximum, means the maximum values of the y. The locally means in some interval they are the maximums. If I take the interval BD, between BD, which is the maximum value of y, R only, means locally between B and D, R has the maximum value, and locally between A and B, which is the maximum, P is the maximum. So I can say P and R, the local maximum of f of x at A and C. At what point they are there? A and C. They are the local maxima, right? Q and S. Points Q and S, they are the minimum values of y, right? Locally they are minimum. Q will be locally minimum if you consider this much interval A and C. Between A and C, where the y is going towards minimum value, that is at Q only. At y equal to Q means at x equals to B, y will be Q, which is a minimum value. But in this interval, if you take the CD interval, the S will be the minimum. So you can say Q and S are the local minimum values of y, right? So local minima of f of x at b and d. At what point they are there? At x equals to b, y has the value of q. At x equals to d, what is y? Y equals to s. Right? So at b and d, the local minima, q and s, I can say they are the local minima. Now we will see how to find the maxima and minima of any curve or any function. Right? So guys, here is the procedure to find out the maxima and minima, that is local maxima and local minima values. Let y is equal to f of x be the given function. Any function is given, y equal to f of x. For example, y equal to x cube or y equal to x square plus 2x plus c, right? Or y is equals to x raised to 5 or sin x cos x, whatever it is, right? Y is a function given. First find the dy by dx, the differentiation of the function. Now what you need to do? Equate that dy by dx equal to 0. Right? Because we always know that at local maxima and local minima, always what is there? The function, the differentiation is equal to 0. That is slope is 0. Horizontal slope will be there. At peak points are having 0 slope. Peak points may be the maxima value or the minima value. Right? So slope is equal to 0. Dy by dx equal to 0. Now find the value of x, means at what point, at what all the points there is a 0 slope values. They are known as the stationary points. But we don't know the nature there. Means whether that point is in the maxima value or in the minima value. So just find the points by equating the differentiation equal to 0. Then find the second derivative. Here comes the use of the second derivative. Because at that point, if the second derivative comes out to be a positive, so what is the conclusion? If second derivative positive at any point, what kind of a curve? We have discussed it. The shape of the curve will be a concave curve. Second derivative positive means like concave curve, like this. Correct? Concave. So if it is a concave curve, at this point, which is a extreme point, either maxima or minima, then of course this is lying at minima, right? If second derivative comes out to be positive at the point where we found out slope equal to 0, then we can say that point represents the local minima value, because concave always go to the minimum and then it rises like that, right? So y goes to the minimum value at a concave curve. If it is a convex curve like this, then y is going to a maximum value like this. Y is increasing locally maximum value, but if it is a concave, locally it will be falling down, that is minimum value. So if second derivative comes out to be a negative value, what is less than 0 means what? Second derivative is negative. Second derivative negative means what? It is a convex curve, like this convex curve. So this point we are interested in, this point we found out, that is at x points, that is, let the point be A, means at x equals to A. Here we get the point, right? So this is the point A. So at this point, if I get the second derivative as negative, it is a convex curve, and convex curve represents me the local maxima value. So then f of x has local maxima at x equals to A. Then if second derivative comes out to be a 0, then what to do? If second derivative comes out to be 0, then the test will fail. The procedure, this test fails. Then what you need to do? Find the third derivative. If the third derivative is non-zero, if the third derivative at that point is non-zero, then we can conclude that that particular stationary point is a point of inflection. There is neither maxima nor minima. There is a change in shape of the curve like this. This is a inflection point, means here concave is there, here convex is there, like that. Shape is changing. For example, this one, this is the convex concave. At this point there is a change in shape. So this point is nothing but the point of inflection. When it happens, when the second derivative at that point also becomes 0, but third derivative is non-zero, right? So then you can decide it like that. All the 3 points, the local minima, local maxima and inflection point. So let us solve them with some examples, you will understand. Okay, let us take an example, y equal to x cube. See, if you know the nature of the curve of y equal to x cube, then there is no problem. Easily you can identify the points. See, this is x equal to 0. At x equal to 0, there is a change of shape, that is convex to concave. But if I don't know this part, then let me find out the maxima minima values, right? Or the stationary points. Now, dy by dx equal to 0. First procedure that we need to do is dy by dx is equal to 0. The slope dy by dx is equated to 0. Then what I will be getting? What is dy by dx of x cube? X cube becomes 3x square equal to 0. So x equal to 0. X equal to 0 is a stationary point. What is the meaning of stationary point? But x equal to 0 is a point where slope is becoming 0. Right? Slope is becoming 0. That means there is some point where either maxima can exist or minima can exist, or there is a point of inflection can exist, right? Means it is giving me some, some signal, right? X equal to 0. This stationary point always give you some signal that there is something at that point in the curve, right? So now let us find out what this stationary point is giving me actually. So for that you need to find out this double derivative, second derivative of the function. Now what is the second derivative of x cube? First derivative will be 3x square, second derivative is 6x, right? So second derivative is 6x. The 3x square becomes 6x. Now at this point, stationary point, what is the value of second derivative? Second derivative at x equal to 0. If I put x equal to 0, the stationary point in this one, second derivative, what I will be getting? Equals to 0 I am getting, right? Now, if second derivative is 0, then test fails. That we have already discussed. If second derivative becomes positive, what will be the conclusion? Second derivative is positive, means concave curve. Concave shape means it is a local minima value, correct? Now second derivative becomes negative, means convex curve. Negative means convex curve, and convex curve indicates what? Local maxima value. But second derivative equal to 0, what it implies? It does not directly imply you the point of inflection. No, it just tells you the test fails. Now if you want to know whether this point is a point of inflection or not, then you need to proceed to the third derivative. Now what is the third derivative of this function? 3x square is the first derivative, second derivative will be 6x, right? And third derivative will be 6 only. Now if third derivative at that point, if you find that point also it is 6, because anyway it is a constant. Even if you put x equal to 0 anywhere, here there is no x term at all. So at any value of x, it is 6 only. So if third derivative is non-zero, that we have discussed, right? So it becomes 6. So it is a non-zero value. So then I can say x equal to 0 is the point of inflection. What is the meaning? Point of inflection is that point where the curve is changing its shape from convex to concave. So here at x equal to 0, we can observe here convex shape is changing to concave shape, right? So this is the point of inflection. So this is how to find it. So guys, here if you want to find out the absolute maximum of the continuous function in the interval given is a comma b, that is from x equals to a to x equals to b. In this interval, if you want to find out the absolute value, which is absolute maximum or the here absolute minimum, will be discussing. So absolute maximum, what is the absolute maximum in this function? For the interval a comma b, it is nothing but the maximum of the local extremes. Means first you need to find the local extremes, right? In a comma b, if you equate the differentiation of y, dy by dx equal to 0, you will be getting the local values, right? The local extremes. Those local extreme values and including a and b. How many points we will be getting? X equals to a is 1 point, x equal to b is also 1 point, and x equal to c and d. Some other points if you get after doing the dy by dx equal to 0, some other points you will be getting. They are also stationary points. So in all those points, find out where there is a maximum value, right? So that will be the absolute maximum in that interval. So maximum of f of a, f of b, that is local extremes, that is f of x in the interval of a comma b. Now what is the absolute minimum value? Means where is the curve is going to get a minimum value. That too in the interval given a comma b, an interval is given, then you will be equating the dy by dx equal to 0, right? So there you will be getting the stationary points. Those things we will be seeing with examples also. Now what is the absolute minimum? No. Now find the wherever the points are representing the minimum values and take the absolute minimum of those values. Means among them whichever is the least value, that value is known as the absolute minimum, right? So minimum of f of a, f of b, or any other points also, if you get stationary points, among them the minimum value you need to find, then that will be known as the absolute minimum value. For example, let me take this one, the sin x curve. So in the sin x curve, what is the absolute maximum value? Sin x, we know that sin x always goes to 1, plus 1 and minus 1. It fluctuates between plus 1 and minus 1. So what is the absolute maximum of sin x? It is plus 1. Absolute minimum of sin x is the minus 1 only. So this is minus 1, right? Absolute minimum of sin x is minus 1. Now what about the mod x? So we know the mod x curve is this one. So where is the function going to minimum value? At x equals to 0. At x equal to 0, what will be the value of y? Y is also 0. So absolute minimum of mod x is 0. Where is the absolute maximum? It goes on. It goes to infinity also. So you cannot find the absolute maximum for this one. Because if I put x equal to 10,000, then y takes 10,000 value. Right? If you put x equals to 1 lakh also, y will be 1 lakh. Like that. So y does not, this maximum value does not exist for this one. Absolutely you cannot say this is the maximum value. Whatever maximum value you give for the x, that one only it will take. But minimum will exist. Minimum x equal to 0 is there. Below that, y will not go. Y is always a 0 or a positive value because it is a magnitude of x. Right? Now absolute minimum of x cube. If you know the curve of x cube, this is the curve of x cube, right? What is the absolute minimum of x cube? It will not exist. See, absolute minimum can go up to minus infinity also. Absolute maximum can go up to plus infinity also. So there is no absolute value for the minimum or maximum values. So minimum value of absolute for the x cube curve does not exist. Y equal to x cube. Even the maximum value does not exist here. So again, we'll be seeing with the examples in the next class. Thank you guys.